to think everybody can see us anyway. So good afternoon.
TikTok.
Good evening. Yes.
20
Yes.
seconds.
What are you chuckling about?
It is the awkward silence right now.
It is the awkward silence
While we're
as we,
getting everything else set up right now. So
as we wait for the countdown.
yeah, that's right. So, but I know there's others that can see us already. Those of them on GoToWebinar. Yep.
Oh, there it is.
All right.
Alrighty.
All right. What's happening, everybody? Welcome to another edition of Takeo After Dark, episode 7.
Do we have to explain ourselves at this point, Dave?
Oh, definitely.
Well, you and I might have to. Jason and Tony probably they look normal, but what's up with that? What's up with the shirt, dude?
Well, it is Halloween.
Well,
right?
yes,
And-
I know.
and of course, me being with all the Hawaiian shirts out there and the Takeo After Dark Hawaiian, I went to Halloween Hawaiian. So why
there
not,
you
of
go.
course. Yes.
I didn't know. I didn't realize it was Halloween. This is how I normally dress on Wednesday nights. So
Yeah,
that is a fantastic hat. You are correct. It is a fantastic hat. I got this hat from my wife for Christmas last year.
So,
And guess what? It fits me
it's a-
like a
It does
glove.
fit well, huh?
Yeah,
Okay. All
there you
right.
go. And it goes with the sequin jacket. I think
Dashing.
Yeah.
Yes.
And Jason, what are you dressed up as?
I didn't get the memo that we were going to dress up for this episode, so I'm just going to default to laid back California guy.
Chill California
Like,
dude. There you
chill
go.
California guy.
And Tony first from the Takeo Commercial Training Department. Welcome, Tony. Tony is dressed up as the adult in the room. Thank you, Tony. Thank you for that, Tony.
Yes.
Tony's our special guest tonight. Thank you for joining us, my man.
Hey, glad to be here. Looking forward to this. We've talked many times about Takeo After Dark and possibly me joining, and it just worked out this week.
Oh, actually, we're thrilled to have you with us. Tony's going to be our special guest tonight, and Tony has maybe one of the most interesting backgrounds of anybody I've encountered in our business. Tony teaches. He's our road dog, and he goes out there and he teaches on big shit. I mean, the really big stuff. Chillers and big base mounted pumps and massive commercial systems, stuff that I look at it and I feel like about this small because I don't know what the heck's going on.
It is basically the stuff that doesn't come in a box.
Right. It's the
Everything
stuff
that comes in a box is what the other three of us do.
right. If we could literally pick it up, then we could
Mm-hmm.
train on it. The stuff that Tony talks about, you need cranes and stuff, right, to pick these things up.
You build the buildings around the equipment first. Yeah, you put
There
the
you
equipment
go.
in, then you put the building around it. Yeah.
There you go. And I think we've got an early candidate for one of our better comments. Rich McGrath says Tony uses the same shampoo as Dave and Jason.
You know what? McGrath doesn't disappoint. He
He
comes
never
up with
disappoints.
good-
Never disappoints.
Love you, buddy.
Well, in my case, it really has to do with 9 kids and 19 grandkids that have done this to me.
Oh my
Who
God.
wore it better though? Who wore it better?
Yeah, well,
So let's not let that go past us. 9 kids
yes,
and 18 grandchildren.
19 grandchildren. And are you ready for this? I just found out last Friday, number 20 is on the way.
Oh my God. Okay, so you're the husband of that old woman who lived in the shoe, right? With so many kids. Okay, that's you. All right. I was wondering who was behind that.
Don't ask how I managed to have 9 kids and as
Oh,
much
I got the memo on that. I know how that works.
Yeah.
So Tony, what tell us about yourself. Again, you have an interesting background and you've done some amazing stuff in this industry. Tell us about how you started. Your first job in the industry was to blow stuff up, right?
Well, that was the first really important job. Before that, I grew up in this industry. My dad was a mechanical contractor. So, most kids, especially my age, we grew up playing with erector sets and Lincoln logs and all that. I grew up putting pipe fittings together. And I constantly got in trouble with my dad because I was out rearranging and making a mess in his shop. taking fittings out of the bins and putting stuff together, and then I didn't put them away, and that created all kinds of havoc. And Dad figured out, well, if you're going to do that, you might as well start learning how to do it for real. So I learned how to make pipe nipples and moved to doing plumbing and changing disposals and changing faucets out, and that grew into out working on boilers and working on chillers and refrigeration systems. And then I decided that I needed to go to college. So I went to college, got a degree in mechanical engineering, and got out of school and got recruited by Train Company to come to work for Train Company. And I went to work for Train. I was a failure analytics engineer in the chiller business unit, which is a really fancy term for I got to break stuff. My job was to break centrifugal chillers and make them do things that we hope customers never do, but we know customers do strange things. And then I got to tear them apart and figure out why they broke and what we could do to make it better. And I did that I was with Train for 28 years, left Train, left lacrosse, came back to Ohio, went to work for a consulting engineering firm where I was director of forensic engineering, and spent a lot of time out looking at job sites and going, this isn't going to work. Here's why it's not going to work. Here's what we got to do to fix it. I spent a lot of time with young engineers, teaching them what not to do and redlining drawings. And from there, I went to work for another pump company, who shall remain nameless. But a year and a half ago, I got the opportunity. I've known Taco for a number of years. Way back when I was working at a consulting engineering firm, Taco was my pump of choice. And last year, I got the opportunity to join the Taco family and work with an absolutely incredible team of trainers, with you three and my two counterparts on the commercial side, Brett and Rich. And the rest, as they say, is history. I've been here a year and a half, and I absolutely love it. I get to run around the country, spending time with engineers and our commercial reps and even our wholesale reps to a point, talking about commercial HVAC systems and piping and chillers and boilers and how to make systems better. And I think what I really enjoy about it is I get to teach based on a lot of experiences I've had in my life and some of the mistakes I've seen, and helping young engineers not make the same mistakes I've seen happen.
Mm-hmm.
That's cool.
Yeah, and I'm passionate about what I do. Every one of my presentations, I start out with a very simple motto, and it's knowledge not shared is knowledge lost. I got a lot of stuff rattling around up here in the head. I got to get it out. Otherwise it makes too much other noise.
Yeah. Yeah. And at our age, we only have so much random access memory, right?
Yes, exactly.
Well, what are some of the crazier things that you have seen out there? I mean, you said how to see the mistakes that you've come across over your career. What are some of the crazier things that you've seen happen out there? And did anything blow up?
Oh yeah, I've had steam to water heat exchangers get pipes incorrectly, so that the condensate, they tried to lift the condensate up in the air and they didn't have enough steam pressure to it and crushed tubes and heat exchangers, which is pretty impressive when you take a 5/8 inch diameter tube and literally crush it like an aluminum can. Because the pressure change that happens when steam hits water inside a heat exchanger and the rapid expansion.
Yep.
I've done a couple boiler explosion investigations. One was a Cleaver Brooks 500 horsepower fire tube boiler. The boiler dry fired, so it was running at high fire with no water in it. The maintenance guy walked in the boiler room, saw the boiler still running, thought everything was okay, turned the feed water pump on. Bad things happen when really cold water hits really hot steel.
Mm-hmm.
Launched the boiler out of the room.
Oh dear.
Oh yeah, launched it out onto the manufacturing plant floor. It took out an overhead door. The back door on the boiler, the back door alone weighs 5,000 pounds. It launched the back door out the boiler room wall to the outside, took out a pedestrian bridge, took out 8 cars, and landed 500 yards away from the building.
Holy crap.
Yeah.
That's a
No one was
projectile.
hurt. No one was hurt,
And,
right?
they had the individual that had turned the feed water pump on.
Oof.
He did get some burns, but he was still alive. He got caught in the debris field, so he had some burns and some minor injuries, but he survived. But the incident where it happened, they actually called the police because they thought it was a bomb going off.
Oof.
Yeah.
Wow. Wow.
And what we found, the scary part that what we found was it was all maintenance error that caused the problem.
Mm.
Somebody had inadvertently put the wrong electronic low water cutoff relay in it, so it closed instead of opened when it dropped on low water.
Oh dear.
Yeah.
And it's a simple mistake. It's a little
yeah.
mistake, but it has big.
Little mistake, but catastrophic damage. They're lucky that nobody got killed. The only reason nobody on the plant floor was killed is because it was at lunch break when it happened.
Oh wow.
If
Wow.
the plant had been in operation at the moment, they would have had hundreds of people killed.
Well, that's why Dave was saying earlier with residential, big mistakes may have smaller consequences, but in a commercial system, a little mistake can have massive consequences, just like just what we were saying.
Right. Well, everybody's got to understand that in a hot water boiler or a steam boiler, if it runs out of water and that boiler is hot because it's dry fired, so it's still firing even though it doesn't have any water in it because your safeties don't work. If you introduce cold water to that, and mind you, on a steam boiler, you may be introducing 212-degree water.
Mm.
Well, that boiler's at 500 or 600 degrees. That water's cold compared to the boiler.
Right.
And what we have to understand is a gallon of water turns into about 6,000 gallons of steam. So the rapid expansion, the sheer force of that expansion is just phenomenal.
Wow.
Somewhere in my archives, I've got pictures of it. When you see it, you're just amazed at the sheer damage that was done.
Oof. So that brings me to two different questions. And the first one's kind of slightly off topic, but it was brought up here by Alex on YouTube Live, who apparently was at our last training class and somehow thinks oatmeal raisin cookies are awesome. Tony, what is your opinion of oatmeal raisin cookies? Why do they suck?
No, oatmeal raisin cookies are my favorite cookies.
Oh, man.
Jeez, no, man.
We were becoming friends, Dave, or Tony. We were becoming friends.
No. Sorry. Yeah, I go on.
I typically have a dozen or two oatmeal raisin cookies at home at any one point in time.
Because they're good for you too.
Yeah, exactly.
And they're healthy. They're healthy.
They're
That's
healthy.
why.
They got fiber in them. At our age, I need all the fiber I can get.
Well, okay, I get the fiber thing, but the raisins destroy a good cookie. Raisins are rotted grapes, people. Don't you understand?
No, they're not rotted grapes. They're dried grapes. There's a difference.
Same thing. You leave a grape out in the sun, it rots. Come on. All
Raisins don't belong in any desserts.
Raisins belong in one place, the same place as kale. That's the garbage can.
I put raisins in my oatmeal in the morning.
Well, you like oatmeal raisin cookies, so there's just no accounting for that. I mean,
The
I put
difference
peanut
between
butter in my
sugar
oatmeal.
and wheat, yes.
All right. Sorry, this has gone sideways in a hurry. What is your favorite thing to teach?
I think because I worked for a chiller manufacturer for so long, I really love teaching chiller plant design and explaining to engineers, the code that we design to on commercial buildings for energy is ASHRAE 90.1. And ASHRAE 90.1 mandates constant primary, variable speed secondary. And I love showing engineers why primary secondary doesn't work. And I've got some great drawings that show why it doesn't work, and I explain what is happening. And then I explain chiller efficiencies and how, if I can decrease the lift or the differential between suction and discharge pressure across the compressor, how I can increase the energy efficiency. And as I start to explain it, I love watching the light bulbs come on around the room and the engineers going, oh my God, I never understood that. I never understood why it didn't work. And as soon as they understand it, then I can lead them down the pathway of, okay, here's how to take that design and make it better and make it work the way you want it to and the way it's supposed to get you the energy efficiency you expect. And seeing those light bulbs come on, and I just did a class last week in St. Louis for our rep. And I had engineers in the room that are in their late 40s, early 50s, and they're going, nobody's ever explained that to me. And they're going, wow, I'm going back and fix my designs. Can I send some designs to you and can you help me fix them? That's what makes this worthwhile, is that I'm having an impact on the industry.
That's cool.
All right, good. Yeah, we none of us
Cool.
came out of the womb knowing this stuff. We learned it along the way, right?
Yeah.
And as you said, and as I think Robert Kaplan pointed out he shared a quote too. It says, knowledge is wasted when it isn't shared. Yeah, somebody taught us. It's it's good for us to share this. I'm gonna go out on a limb here, and I'm gonna give Articuno at Articuno Alex on Facebook or on YouTube Live. First winner of our Carhartt watch cap giveaway for tonight. We're going to give away 3, 4, maybe 5 Carhartt watch caps. Do me a favor, Alex. Just send a text to Christina, if you're still there. If you can get Alex's info off of.
I'm coming in from above.
Ooh.
What? Congratulations, Alex. Where was Alex? What platform is he sitting on?
He is on
this one?
YouTube.
He's
YouTube
on
Live.
YouTube?
Yep.
All right, I'll go catch him over there. Thank you,
All right.
gents.
Way to go, Alex. You won the first Carhartt cap, and Christina will get your information. And again, best comments we get tonight, totally subjective. We get to pick what we want, whoever we want to pick.
Comments, questions everywhere on every platform we got going on right now.
Come on, YouTubers, get busy on YouTube.
Webinar, yeah, yep.
There you go. And I go Jorge on LinkedIn Live. I think he's on my side about this oatmeal raisin cookie debacle. Don't they just have a ton of sugar? That's all sugar. It's not good for you. It's and not only that, they suck. I guess the other way.
Well, I know what cookies not to give John now.
Well, there you go. That's right. And,
So I was thinking of the comments before, the differences and the similarities between, commercial hydronics, residential hydronics, and yes, there's a lot of similarities behind them, and there's also a lot of big differences also between those two things. And I was thinking of another variable on how we define the differences between them, and I'll take your take on this too, Tony. But the one thing I thought of was a lot of commercial hydronics is well designed before anybody puts anything into the building. Whereas I find a lot of our hydronics, a lot of residential hydronics, we're designing while we're standing there staring at a blank wall.
Yes.
The house is already there, built around us, and now we're designing the systems from there. So, what do you see on some of the big differences between systems out there?
So, Dave, I think that's one key point is commercial systems. You have a professional engineer that's designing it, and he's going to lay out the piping, and he's going to size the piping, and because there's a lot more that goes into it. What you have to understand in a commercial hydronic system, it's not just the boiler and the pumps and the chiller and the pumps. There's cooling towers, there's all the air handlers in the building, there's all the ductwork, you've got VAV boxes. There's a lot of different parts that all have to work together. Okay, and that doesn't even touch the plumbing side of it. Plumbing side's a whole nother side of that equation. And so mistakes on the commercial world are big and costly. To give you an idea, I just had this conversation today with our rep up here. An engineer designed a job and missed his head calculations on his pumps. The
Wait a minute. Missed the head calculations?
Oh,
I mean,
yeah.
Skipped them or just was incorrect?
Just was incorrect by about 35%.
Oops.
He was low. And so the problem is he's come back and said, oh, no, I made a mistake. They've already ordered the pumps. He's already approved the submittals.
Yep. Long lead times.
Yeah, well, and the problem is it's not as simple as just changing an impeller. The casings have to get bigger and the motors have to get bigger. These went from, I want to say, 75 horsepower to 125 horsepower. This is $1 million mistake. So mistakes are a lot more painful on the commercial side. You know, there's lots more checks and balances in the commercial design world in looking at the design to make sure everything is correct. But I can tell you, they are not always right. They do make mistakes. You know, my goal when I was working for a consulting firm was to correct the mistakes before they left the paper side of it and became a job. Because when it's lines on paper, it's easy to fix. Once it becomes pipe in the air, it gets really, really expensive. So the key to it is that's probably the biggest single difference. You know, it still follows, Dave, it still follows the same universal hydronics formula. BTUs equals 500 times GPM times delta T.
Yep.
Now, when we move into the commercial world, we see a lot more glycol. Okay, so we have glycol systems for heating, we have glycol systems for cooling, and 500 no longer becomes the constant, but it's still the same formula. All we got to do is change for specific gravity and weight of the fluid. It's still the amount of fluid circulated in an hour.
Yep, I agree.
Yep. And
I agree.
it is there are certain universal things, but again, everything's commercial stuff intimidates me. I got to be honest. I mean, when I was working with the tools, someone said, "Hey, I got this. Can you come look at this school?" And I go, "No, I can't. It's outside of my wheelhouse. I would walk in and I wouldn't know what the hell I was looking at."
You know, and John, what I will tell people, you know, for all of you out there that are in residential, maybe light commercial service right now, don't be afraid to want to move forward and learn commercial service. So, you know, yeah, the equipment's bigger, you know, boilers, you know, 23 million BTU boiler, not a big deal in the commercial world. 23 million BTU is heating a whole lot of houses in the residential world. Okay. You know, I've done chillers. I think the largest chiller I've done is 7,500 tons in a single piece of equipment.
Hokey smoke.
Oh yeah, big machine. You know, but the thing is, what you got to understand is in the commercial world, heat transfer is heat transfer. It follows all the same rules. You know, in a residential hot water heating system, you got zone valves, right? Zone valves open and close to allow water into the radiators, right? Simple. Well, I got the same thing in a commercial building. I just got air handlers. I got pin tube radiation. I got fan coils. So in the same building, I may have pin tube radiation. I may have fan coils. I may have reheat boxes. I may have air handlers. I'm still transferring energy.
Right.
They get bigger. They get spread out. Don't be afraid to learn that side of our business. There is really good money to be made in the commercial HVAC service world.
That's the part they left out.
Yeah.
About the good money to be made.
You know, yeah, working on rooftops in the wintertime sucks. You know, it's cold out there. It sucks working on it in the summertime. It's hot out there. But guess what? If you learn this stuff, you can really do well financially. Don't be afraid of it. Do everything you can to learn more.
And that's true, I guess, across all aspects too at the same time, right?
Yeah.
I mean, that's the big part that we do on the residential side as well. You know, we're trying to teach, you know, we're not, you know, when we do the training classes down in Rhode Island, and we got a group of 2 weeks ago, we had 40 people in the room, and you know, we didn't sit there and show them how to put pumps in, right? We
Right.
said, all right, why are you holding this pump, and what
Right.
value did it have? You know,
Right.
to you and the customer itself at the same time. So, but we do find that you have to try hard in the morning to screw up a residential hydronics job. I'm not saying it's impossible, All right, but you got to try hard. You got to wake up and
Yeah.
say, you know what? I'm going to mess this job up today on purpose. All right. It is we do get a lot of forgiveness in our systems as well. We are also way oversized for a lot of our equipment, just for the sheer nature of the designs and the components
Mhm.
available. You know, we don't have the option to trim impellers on our circulators and whatnot. So, and we can't get too small on some of our boilers that we have available and things like that. So yeah, we're going to be oversized and we're going to be safe, you know?
Right. Well,
So-
and Dave, you brought up a good point. You just made the comment about trimming impellers. And in today's market, we don't trim impellers because we've got a variable speed drive on the pump. So I'm going to dial the pump in to match the system. You know, and one of the downsides to engineers, and it's not a downside, it's just a reality of design. So you have to understand that when an engineer designs a building, he puts his seal on that drawing as a registered professional engineer. He owns the liability for that system for 7 years. Okay, so, you know, he's really striving to get it right the first time. And so they tend to oversize systems. And with an oversized system, it creates lots and lots of problems. So I teach engineers to not put tons of safety factor in.
Right.
And go back and look at the design after you've got it designed and know what the real load is on the building, and add safety factor where it makes sense. And you'll get a much better design that's not as oversized. But the other thing we have to understand is when I look at a commercial HVAC system, commercial HVAC systems, especially, are part load systems. So did you know that a commercial HVAC system spends 90% of its time operating at 60% or less of full load?
Mhm. Yep.
And so if you think-
Residential ones too.
it's just a residential system's a little more forgiving. Well, if I've really screwed up the sizing on a commercial building, now what ends up happening is that if it's grossly oversized, the efficiency really falls off as I try to run at that light load condition. So engineers have gotten more conscious about it. They're starting to pay more attention to the piping. You know, on chilled water systems, we did primary, secondary for years with a constant speed primary and a variable speed secondary. We're moving away from that. We're moving away to variable speed chillers and all variable systems, so that all the water is variable. And we're doing flow matching to load match the production versus the system load. So everything is evolving. And so, you know, this is why I strive to learn something new every day, to stay on top of all the stuff that's coming down the pipeline.
Yeah, there you go.
Yeah, it's hard to
Full-time
keep up
job.
some days nowadays.
Yeah.
Yeah,
It
I
is.
agree.
That's cool stuff, Tony. I think I found my favorite comment though thus far.
Yes.
To the man in blue, dressed like a magician, will he pull a rabbit or a 007E out of that hat? Send that man a hat.
We'll see.
Or
We'll
woman.
see.
Oh, he deserves a hat. Deserves a hat for that comment.
There you go.
Uh,
There's a hat for that comment. Vital Rights, what is 7390? Give Christina your information. She'll send you a fantastic. Not going to send you this hat. This hat's mine.
not that particular hat.
This is my wife's. You will
Tony
get
will send you some oatmeal cookies along with
yeah,
that.
you get some oatmeal cookies. Oatmeal cookies, yeah. Okay.
That's cool
yeah, I
stuff,
know.
Tony.
If you haven't been to TACO in a couple of decades, as I'm seeing here, many decades ago, make sure you come back. Come visit us, man.
Yep.
Get in touch with me. Make sure I'm in town. You know, I can set you up and we can do a tour or something like that. So don't hesitate to reach out and come visit again, man. It's been a lot different heck, I've been here 13 years now, and it's a lot different. So
Yeah.
new training center and the factory in the back is different. And come on by, brother. Come on by.
You know,
Robert Jameson backed that up with Thermal Appliance Company for Life. There you go, brother. I love it.
Nice.
I love it.
Love the YouTube contributions. Great stuff.
All
Don,
right.
to give you an idea, way back when I first got introduced to TACO, I'd used Takeo pumps for quite a while up until that point, but I was invited to come up to a Takeo U class long time ago, before the Innovation Center ever got built.
Oh boy, we had that little closet of a room. Yeah.
Yeah, and Greg Cunniff was who was teaching the class, and that's when I first met Johnny, and got introduced to what Takeo really and truly is, and everything that they were trying to do. And they tried to get me to come to work for them not long after that, but they wanted me to live in Rhode Island, and my wife's like, no, we left La Crosse, we've left cold climates, we're not moving back north again. And so we stayed in Ohio.
There you go. There you go. Well, we're glad you're with us now, Tony. We do appreciate it, and thank you for being our guest tonight. I hope you enjoyed this as much as we did, because
It's fun.
I do need to tell you though that I have issued a command decision as director of this department to our marketing department that we will no longer have oatmeal raisin cookies during our factory training classes. They are forbidden.
I agree.
It's okay. As long as they're always forbidden in your classes, John, we're fine.
Hey, Tony, I've always wanted to say this to you. If you're not first, you're last, right?
I've been first my whole life, bro.
My man.
We might have to give Jason a hat for that one. That was pretty good.
That was good.
My
I had
man.
to come on real quick because I do like oatmeal raisin cookies, and I'll make sure that they're everywhere now that I know that you hate them.
Oh, torture. Don't upset the boss.
I'm sorry, with a certain
Am I fighting?
level of managerial stature, you're supposed to have power, okay? You're supposed to be able to make decisions
And what dreamer are you talking about, John?
for whatever reason. You don't even need a reason, right? Can't I just say no oatmeal raisin cookies because I said so?
Executive order.
The cookies look like oatmeal raisin and trick you.
Do you see out there, friends in webinar land, what I have to put up with? Just the lack.
Don't do that.
What we're dealing with here is a total lack of respect for the law.
Don't do that. I got to work with them after
Reasons
that.
to like you. You know that, don't you?
Do what?
Christina's giving me even more reasons to like her. As to ways to torment you, John.
Oh, man. Dave, do your thing, man. I'm
Do
just
your
going to
thing,
go sit.
Dave.
I'm going to go sit in the corner
I gave
by
away a hat
myself.
too, by the way. Bye, everyone.
Bye.
Take it away, Dave.
All right. I guess this is the training section piece, everybody. So we got to go over it. We had Tony. Tony, thank you very much. Awesome that you joined us tonight. Obviously, you can stay.
Thanks,
I'm
guys.
not kicking you out or anything like that. But now we've got the training portion of Takeo After Dark, based on what Takeo After Dark started on, right? And morphed into our new version, into this realm that we're at now. So and having a lot of fun streaming everywhere. So, but we are going to talk about controls. And the new Dash 5s, but not the whole Dash 5s, because you know what? I talked about it yesterday a lot. All right, we had Takeo Tuesday yesterday, which was a little bit of a deep dive into the controls, and today I'm just going to dive a little bit deeper into one of the components, our PC800 tonight, is what I want to talk about. And this add-on component that we have to our Dash 5 controls can really change a lot of what your systems are doing and how you can really customize them to your project. So we're going to talk about that PC800. And there you can see a picture of the Dash 5 control itself. And that component right there in the middle is the PC800. It snaps in. It comes as a separate component. It doesn't come with the controls. Because when you're looking at your switching relays, your zone valve controls, you may not need to use this, or it depends on the system you're working with at the time. So what you have here is this component right here. Plug it in. It snaps into any of the Dash 5 controls, and it stands off the board just a little bit. It will come with one temperature sensor, and we've got some terminals on here. So I want to go into a little bit of detail on this controller. Okay. So as we zoom in, you're going to see a couple of extra terminals that are added to this board. And of course, there's a whole bunch of code that's written to here as well. So you'll see here, it shows all the way starting off on the right-hand side, you'll see the outdoor sensor terminal, a boiler sensor, and then an output terminal. And so what this controller is doing is adding either outdoor reset to your boiler, or it's going to add indoor reset or load compensation to your project. And I'll go into some detail with that in a little bit. So you've got load compensation or weather compensation, and which one's better, where, and why. You know, there's some variables that come into play when thinking about that. What we also have on here is a terminal, that output terminal, and you'll see the plus minus button there, and that is our communication terminal to now go talk to something else, meaning your boiler for a chance. You know, you may have a boiler on a project that has a 0 to 10 input or a 4 to 20 milliamp input as well. And what that's going to do is we're going to talk back to the boiler to tell it how much to fire to. So if you have that terminal as an input onto the boiler itself, what we're going to do is start looking at what's happening and what's going on, and we're going to tell the boiler what to fire to. Now, if you don't have a boiler that has that 0 to 10, you can use that 0 to 10 or 4 to 20 for output to other things like variable speed circulators or mixing valves that have 0 to 10 input, so you can modulate that water temperature. So like I said, you're going to have minimum is going to be a boiler sensor. All right. And that's what comes with the RP kit as you get this whole kit together. You'll have this control, you'll have the terminals, the feet, the mounting feet that go with it, and that one 10K sensor that you see out there. Now, if there's any questions whatsoever on all the platforms right now, unfortunately, I can't see them all. So John and Jason,
I got you.
Christina are paying attention to the chat questions, anything coming up. So make sure you ask a question. We don't do question and answer periods. You got it, you ask it immediately. Okay. Now, if you want this control to do outdoor sensor or outdoor compensation, what you're going to do is make sure you get your outdoor sensor. All right. It doesn't come with the controller. Again, standard 10K outdoor sensor. We have that as an RP part as well. Okay. So just get your hands on that if you are using it for that respect. So it doesn't come, and I just want to make sure you know that. Okay, hang on, sorry. All right, Ellen, like I said before, you can control mixing valves or circulators that have that input. Be really interesting it's really cool to see if there's circulators that have 0 to 10 input where we can control the speed of it. It's just freaking crazy, huh? So yes, we can do that as well. But right now it is designed to go after that boiler option currently. So let's take a look at outdoor reset and what's going on with it with the controller. So here I'm showing you a quick piping diagram, and a wiring diagram of what you're doing. So let's say this is a zone valve, your zone by zone valve system here. You put the ZVC in. You can also control a couple of circulators. You install the PC800, snap it into the middle of the board, wire in your two sensors. You've got your thermostats across the top here, zone valves across the bottom with the circulators. And you can see here, this boiler has the main end switch coming into it. It's got the hot water priority end switch, as well as the 0 to 10 signal coming in. So we're doing some doing the outdoor reset, which means, and I find one thing, when we start talking about outdoor reset to customers, we start telling them things how we talk about outdoor reset. Outdoor reset, you need to talk to homeowners about it, but talk to them in what they understand, and cruise control for your car. It's all about fuel economy and modulation based upon the conditions it sees right at that moment. That's what you really want to look for. So that's what your outdoor reset is. And how you're programming and setting up this control, because yes, this is it's not a Wi-Fi based system where it's looking at weather in your area. It's not learning anything. What it's going to do, you have to give it some parameters, and the Dash 5 controls have a Bluetooth communication protocol, which means you download the Takeo Control app, you put it onto your phone or your tablet, and you communicate to the device through your Bluetooth. It's not pairing, it is just a communication protocol that we're doing. And that allows you to set it up. It's not meant for monitoring or anything like that. It is just strictly for setting it up purposes, installation. When you're there, use it once. It allowed us to not have to install and manufacture an expensive display and interface into here, because everybody already owns the best display they have in their pocket. There was no reason for us to build something like this in there. So that's why we did it via Bluetooth, not Wi-Fi, so you don't have to worry about internet in the house or anything like that. So I want to go through some of the settings in the app and how now you can customize this to your project and to where the house is to give you the best efficiencies that you can get out of a system. Because that's the biggest key you're looking for here.
Before you dive in,
yes, sir.
We've got Robert Jameson, 1959, on the YouTube platform. Says, "Is the boiler sensor a pipe thermistor?"
Yes, these are standard thermistors. Correct. Yes. Yep.
So over the pipe. Yep.
Yeah. So that boiler sensor is
clamp on.
you can do a strap on with a zip tie. I think the zip tie even comes with it as well. Doesn't need to go into a well or doesn't necessarily have to be insulated. I guess it will depend upon your ambient around that boiler room. Never hurts to put a piece of insulation around that sensor. Correct. So
very good. Very good. Thank you.
Okay. All right. So let's see. So let's take a look at the app for a second, okay? And some of the settings that you have. So here's one of the pages, and I grabbed this from my buddy's house. I recently did an install at his house, and we did a radiant floor system. So we were actually able to name the controller underfloor heating. All right, so that's what you see here at the top here. You can actually name the controls, and it's called the underfloor heating. And when you get to the operating mode of the system itself, when the PC800 is installed, you have all these different settings that you can customize to the system. So for example, you have boiler type, and your boiler type right now, you see here, it says on off. But if you had a modulating boiler that had that 0 to 10 input, that would show up on that point and you would make that selection. All right, so you just tap on where it says on off, and a screen is going to pop up, and you get the radio buttons in order to choose which one. Now, this is also where you start looking at your outdoor reset curve, because your outdoor reset is going to modulate the water temperature based upon what temperature it is outside. So you've got a minimum boiler that you want that boiler to make. So if you're looking at, say, a standard cast iron boiler, we probably want to go between that 130, 140 degrees as a minimum temperature of the boiler itself, so it's not condensing, right? So you don't want to have sustained condensation with your boiler. And then you've got your boiler differentials, typically cast iron. We might look at a 20. Check with the manufacturers on what they prefer to see on there. Okay. So you always want to read that manual from the manufacturer out there on what they have for a boiler differential. And then you get your reset ratio. And your reset ratio here is going to be a number that you're going to type in, or it's going to be a slider bar that we have chosen there. And you got to do a calculation and figure out what your reset ratio is. And your reset ratio is going to be, what is my water temperature change rate versus my outside air temperature change. And there's a couple of ways that we can do that, and you can find that in the instructions themselves. So for example, your reset ratio, as you see here, has all these different curves, and it is a function of your outdoor air temperature to the supply water temperature that you have in the system. So there's a couple of different ways that we can figure it out. First way is by this formula, and you know us, we're going to have a formula somewhere where we're going to do some math, but it's not going to be that hard. All right, we're not turning our phone sideways in the calculator mode to go scientific. We're just doing some simple subtraction and division here. So you take your design supply temperature. So what water temperature do you need out to your hydronic system? Minus 72 degrees, which would be our indoor design temp. And then divide that by 72 degrees minus your design outdoor temperature. And remember, use your ASHRAE numbers for your outdoor design temperature. Don't go, hey, I think I've seen it get to this temperature in my neck of the woods, or I'm going to add a little bit more, because that starts screwing up the reset ratio, that curve that you got going on there. So for example, in my buddy's house, we were doing a baseboard system as well. And I was showing the math, and his house was way over radiated because we had a 2 temperature system at his place. And so based upon how much baseboard was there, the maximum water temperature I needed was 155 degrees because it was so much more there. We didn't need the boiler to fire up to 180. So we got 155 degrees minus 72 divided by 72 minus 15. 15 degrees above zero is my design temperature here on Long Island. That comes up to 83 divided by 57.
1.4.
1.45. Sorry, what was that?
Oh, I was just guessing the number.
Oh, okay. So what does a reset ratio of 1.45 look like? So when you apply it to the curve, you'll see the curve ratios 0.2 all the way up to 2.2. Well, that's what we're looking at right there. So as you look at this, if my outside design temperature is around 15 degrees, all right, and I'm sorry, wrong way, over here, 15 degrees, we bunch up to here and it's going to see it's about 155, okay? Or 100, yes, or so. But as it warms up outside, we don't need as much heat, so we're going to lower that water temperature. And let's say it's, and I know here on Long Island, an average winter is around 30 degrees outside air temperature. So at 30 degrees, we're going to see a water temperature of about 130 coming out to my baseboard. All right. Now I could have stopped that right there. So I do have at least this modulation of water temperature to my system. So, but in my house, I actually did a mod con boiler. So I put my low end of around 115 degrees. So I can go between 115 and 155 with that. So you can really see how you can make systems more efficient and more comfortable at the same time. Now there's some other
Dave?
ways you can use this chart. Yes, go ahead.
I'm sorry. I wanted to elaborate on something you said earlier about that using the outdoor design temperature and the danger in overestimating that. If you had to use, say, hey, well, it's 15 degrees, but sometimes it gets to 0. I better use 0.
Mm-hmm.
If you throw that in the math formula, 72 minus 0 on the denominator, 72. Now you're dividing 83 by 72. You're going to have a much shallower curve.
Mm-hmm.
And you want that 155 when it's 15. You're not going to have that 155 when it's 15. It'll be too low.
Right.
So that's what over exaggerating. Do you think you're going to be safe? It's going to have the exact opposite effect. You're going to wind up screwing yourself.
Exactly. So, so it's not like we're playing with rocket science here or anything like that. So, but yeah, now all of a sudden you got to come back on those design days when it's not working. All right. And I know everybody out there it was sitting around doing nothing when it hits the design. Right. So yeah, you got to watch out for that. Now there's the other way that you can do it on how to figure out your reset curve here as well. As if you didn't want to do the math here, as long as you got the chart here in front of you, if you've got this chart, all right, what you're going to do is that you take a vertical line from your outside design temperature. Okay, and then you do a horizontal line on your water temperature, and where the two of them meet, that's your reset ratio as well. So that's probably a little bit quicker way, but you got to make sure you have that chart in front of you. So have the chart, have the formula. Either way, you're going to end up with the same result. Okay, so that's your outdoor reset ratio when you are doing a weather compensation system, do an outdoor reset. Okay. And a couple other things here, you'll see you got your boiler max temperature. And then also this becomes very important too to pay attention to is warm weather shutdown. All right, which means what temperature is it outside? I don't care what you do to the thermostats inside the house, the heat doesn't run. All right, we're not firing the boiler. Now, what it does do, it does turn pumps on, but it doesn't make the boiler fire. Okay. So that's one thing that we do have built into the control. So it's going to keep that boiler off. So you program that to whatever temperature you think. The default is going to be 70. Like a lot of people put it around 62 because at that point you're getting a lot of solar gain in your house. If it's 62, 63 degrees outside, there's no reason for it to fire off. All right, how we doing? Any other questions so far?
There was one from Vital Rights, wanted to know if any of the relays being designed use wireless thermostats, wireless or Wi-Fi thermostats. I was great at snaking wires on old houses in Boston area, but it's time to make thermostat communication to the boiler wireless. Dave, you and I have been down that road at a previous employer with wireless thermostats. They're better now, I think, than they were in 2000 whatever, when in the early 2000s when we went down that road. But it's not the relays we have are not wireless equipped. There are wireless thermostats with receivers that you can that should be able to connect to this thing if you so choose, I would imagine.
Yeah, I do remember we did go down that road a couple of years ago, about almost 10 years ago. We were going down that road in some R&D, and we were getting really close. And I remember some of the components that we were working with that we purchased from a manufacturer. we turned around and we were ready to go, and we said, hey, we need to make sure we got to cross our T's and dot our I's, and we need to have the FCC regulations and all your yeah, you know the word I'm talking about. I can't think of it right now.
Well, there's a big
compliance.
security risk there too.
And they said, oh no, we don't have any we don't have any of the FCC stuff. And we're like, wait, what? You can't sell that here if you don't.
Yeah.
We can't manufacture that. We can't install it into our equipment if you don't have that. So we ended up stopped working on it. We got busier with other things, and it didn't come back to light because it was really bringing us back to ground zero on that and starting over again. So we haven't gone after that. So yeah, it's still going to be a hard wire for your thermostats. Now, what we did build into the new controls, and all the new controls do have the all-powerful C terminal. So when you are looking at your Wi-Fi thermostats that are communicating out, we do have that C terminal where a lot of those thermostats need to have that that common connection. So
couple more comments I want to throw out at you, Dave. Juan, who I think is going to win a hat. Christina, get in touch with Juan Nagengast on GoToWebinar. Can the controller be set to prevent oatmeal raisin cookies from entering the building during all weather conditions? I think that should be one of those those updates that we put into this thing. I absolutely believe it. And then Rich McGrath says, tell me how wireless works in a house full of joist track plates.
Yeah. Start adding a lot of aluminum and metal and between floors, and Yep.
It all adds up. But Juan, you got one, and McGrath for that shampoo comment earlier. I think you got a hat coming too. And don't worry, Dave won't be sending that out.
All right. Yeah. It's been taken off my plate. Yes.
Sorry, Dave. Continue.
I haven't been home in this is the first time I've been home in almost 12 weeks.
Welcome home.
Yeah. Yep. Anyhows, all right, let's talk indoor reset or load compensation. And so I've been doing a lot of training on these controls, and people will ask me, so which one is which? Why would you use one over the other? And when I start thinking about it a little bit more, outdoor reset, we've been doing this for a long, long time on outdoor reset. And I started thinking about, what, and it's great. It is awesome to do. I don't want to see a system installed without it anymore, because again, as we've been teaching in a lot of our training classes, your boiler equipment is perfectly sized for 2% of the winter. 98% of the winter is way oversized. Okay, so if we can get some modulation going on there, especially with the boiler and some of the equipment, hey, we're doing that with variable speed circulators, right? And we can modulate water temperatures with mixing valves. And now all of a sudden, let's modulate the water temperature of the boiler. Now you got full system reset. All right, just one thing working by itself. But when we think about outdoor reset, if you really want it to fine tune it and get it to what it's supposed to do, it should never turn off the entire year round. So an outdoor reset system is going to assume, one, the boiler is perfectly matched to the heat loss. I know, I'm reaching. All right. Two, there's one zone in the house. All right. And it is dialed in perfectly. All right. All the system is dialed in exactly. So you've got the right size circulator. You've got the right size. It's basically living in seminar land.
Yeah, and everything is perfectly balanced. The flow through everything is perfectly balanced.
Right.
So it all goes out at exactly the right GPM. That was a question that Eric just asked. Why do you need indoor thermostats with a good outdoor reset curve and warm weather shutdown? Because pipes and rooms and stuff. And it's just that.
Yeah. Internal loads, external loads, everything that still affects those rooms themselves. Exactly. Yeah. If you could dial it in perfectly. I got kind of close in my old office. I did have an outdoor reset that was just set up for basically one zone. And I sat there and tweaked it to that, and only because the people that resided on that side of the building, the thermostat was locked, all right, in a box. You've seen them before in the mall or whatever in the stores. You'll see the thermostat and it's behind a box where nobody can touch. And that's the way it was, but I had a key to it. So I inevitably during the course of the winter, at least twice a week, I was asked to make adjustments. It's too hot, it's too cold, it's this. So then I finally tweaked it all and disconnected the thermostats and took the cover off and said, have fun with it. And everybody was comfortable from that day forward.
It's called psychophysics with heavy emphasis on
It
psycho.
totally was. Yep. So at that point, yes, if you dial in, like I just saw a question pop up or a comment from Robert, yes, they typically should act as a high
Yeah.
limit.
Yeah,
Is
exactly.
really, if it's dialed in correctly, right? So let's take a look at indoor reset, because now indoor says, hey, what's going on inside the building, inside the house, and what you got going on. So here we're only going to use one temperature sensor, and it's the supply side going out of the boiler itself. So as we take a look at the app and some of the settings that you have here, and I'm going to change this one also to show it to show a modulating boiler that has that 0 to 10 input. All right, so I can tell the boiler what to fire to. So again, you've got your different types of boilers. You can have on-off boiler with indoor reset, as well as modulating boilers 0 to 10 or 4 to 20. Now, the beauty behind the control here, for those of you that do some control wiring in regards to 0 to 10 or 4 to 20, a lot of control platforms are doing 4 to 20. And if you have a system that's sending out a 0 to 10, you got to add some resistors to it, right? And you got to cheat the wiring, so to speak. You don't have to do that with this. All you have to do is just choose it, and we're going to do that signal coming out correctly for you there. And so now when you see here, you'll see also minimum modulation. And so this is going to be dependent upon the boiler manufacturer. Again, what is the minimum firing rate that boiler can go to? So if, let's say, you had a 4 to 1 turn down ratio boiler, the minimum modulation is going to be 2 volts, so therefore 20% of the boiler itself. So you do have to choose that in there. Now, this section here I thought was unique. I got a lot of questions on this and say, what is the response time? All right. And the response time is going to depend upon the system that you have installed, which means high mass systems versus low mass systems. So we're looking at, so your high mass systems respond slower to temperature change. So what we're doing with our load compensation is that we're starting the system at a low temperature, and we will ramp upwards as the call for heat happens. We don't know how cold it is outside. We don't know the load on the system, but we're watching what the temperature of the water is going out to the system itself and how long it takes for thermostats to satisfy as well. So therefore, we start ramping the temperature up. And when you say response time, it says, all right, how long do I have to wait before I start taking my sampling back again to respond and change my water temperature? So the settings that you have is slow, medium, and fast, okay? And so the way I like to equate that is, hey, what type of system do you have? And you might take a look at a concrete slab, all right? That's a slow responding system. You can go to panel rads, which is going to be in the medium world, right? It's not a high mass system, it's not low mass. And then you got baseboard and fan coils, which is a very low mass system, right? They heat up quickly, they cool down quickly. So you want to think about what type of heat emitters you have in the building. And then, of course, we have the boiler minimums and the differentials and the high temperatures that you're going to program in. And now, of course, when we start to talk about the highs and the lows, or the min and maxes, you get to do, obviously a lot more flexibility compared to your cast iron boilers. And then you also have this efficiency level. And your efficiency level now starts to, I would probably start with every system, and the default is on medium, okay, or in the middle right there. And you have a couple of different settings. And this is something that you can come back to later on after having a conversation with your customer and ask them about the comfort level in the house versus their efficiencies. So you have low, medium, and high, and how efficient do you want it to be? Do you want your boiler really efficient, or do you want to be really comfortable? Well, still going to be efficient. So, but now it starts thinking about, it's trying to do that little offset of the reset curve, kind of like I was talking about before. So it does those quick, fine tune adjustments rather than doing that pitch change and changing your outside design temperatures that you're going to see. So that's what the efficiency level means. I usually start, like I said, we'll start at that medium, and then you'll adjust it as time goes by as the systems are up and running. So a few other settings here, as we can see, that was just the main boiler page. All right. And as you make those changes, as I said, here you have the radio buttons on, off, modulating 0 to 10, 4 to 20. All right. And what we tried to do with the app itself is to make it somewhat idiot proof, right? Meaning that you can't make a settings change if that piece of equipment you're talking to doesn't have that programming availability. So if I were to choose on off, all right, you go back to the first screen to the left here, and you see that it doesn't have the choice for modulating. Whereas if I came over to here in the third screen, you'll see I chose 0 to 10 modulating. That's when modulation showed up. That's where response time showed up. Okay. So that's where we tried to think about what the app is doing and how you're controlling it. Okay. That you can't make mistakes and choose the wrong programming for the wrong type of system itself, if you know what I mean. Because we know people just sometimes they just don't read stuff and they'll just start clicking on things. So those are some of the settings on the boiler side of things. Here you can see the efficiencies, right? You got that slow, medium, and fast. And again, we do these radio buttons or we do the slider bar so you can get close to the temperatures. And if you can't get exact with the slider bar, because I know how big a lot of people's fingers are, you do have the plus minus button underneath there to help fine tune it. Okay, here you can see some more, the low, medium, and high. All right, again, minimum modulation that's going on. So these are will be questions of the boiler that you have installed and what equipment is going on the project itself. So really trying to define and give a lot of efficiency to your systems themselves. So again, remember this is an add-on to the new Dash 5 controls. That Dash 5 control is the one you look on the outside of it. One, it's going to come in a nice colored box, but you'll also notice a spot for labeling zones. If you notice that, that's a Dash 5 control. You can add that PC 800 to it.
Whew. Take a breath there, Dave.
I know we ran a little low, you know, it's 8 o'clock right now, not too bad.
There you go.
So any questions up to this point?
We covered the ones that we got, I think, along the way. Pretty well.
Chats are clear. Chats are clear.
Yeah.
All right.
And
all right.
You'll notice I took the jacket off and removed the hat. I went with my Takeo headband. Oh, wait a minute, there it is.
No, I don't have the cameras up right now. So there we go.
Oh, there we go. Looking
Okay.
good. Looking good. Late to the party, but hey, there's Daryl Fern. He's a little late to the party. I got to tell you, I think this indoor reset portion of the PC800 for what this thing's going to cost as an add-on is like a serious no-brainer. Snip the wires to the outdoor sensor. Don't even bother. You know, what's going on outdoors is important, but it's reflected by what's going on indoors.
Mm-hmm.
And realistically, do we care what's going on outdoors? We care more about what's happening indoors. And this, I think, gives us the potential for even greater comfort and greater efficiency.
I agree. So my buddy's house, he did have the PC700 in his house with an old Dash 2 control. And so we upgraded it and we added this to it. And I mean, it's only been on for a couple, the last week and a half, where we can really get some heat going into the house right now. So we did make a couple of changes because he did notice a few things going on, because his house is doing baseboard and radiant floor at the same time. So he does have a cast iron boiler. So we're modulating, this is doing the modulation of that and the radiant floor going. So, but he had a couple of things backwards when it came to the response time and the efficiency level. So we swapped them around a little bit and things evened out this week. So it's been operating really well for his house. He's tickled right now on his new radiant system in the house and the new controls running everything right now.
Great.
Very good. Jorge just asked about on LinkedIn. He asked about some literature or information to read. I'm going to presume that is on the PC800. I'm going to get that for you right now. So don't go anywhere. Let me get, there's that book. Yep. But do we have any specific literature on? On
the PC800 directly, no. You're going to look at the IOMs for each of the controls. So whether it's the SR panel or the ZVC, there's a section in there, but we do not have an individual one just for the PC800. Right.
All right, I'm going to put the link in the different chats for
For the wiring guide.
the wiring guide. I guess gotta make this
So,
little screen a
Uh,
little larger.
right now, and I do know that we are also working on a quick hit guide on the app itself. So that'll come out where you'll see these screens with descriptions and how to use it and set up and stuff like that, what the defaults and ranges are. So that will be coming up in the future. All right. Picks from the field.
All right.
Time for picks from the field. All right, and you know what? And I know we got a lot of people here, you know, from different platforms, Facebook and YouTube and whatnot, and we see lots of job sites and lots of customers and peers out there putting projects out there, you know, things that they work on. And as everything in regards to the internet, you know, everybody's gets, you know, I don't know why, but everybody loves bashing. You know,
Oh yeah.
you know, and so we wanted to celebrate, and that's what we do with picks from the field. So for you, those of you that have joined us, you see that QR code right there, scan it, submit some photos, all right, job sites, and we're going to bring them into our social media pages as well as Takeaway After Dark as well. All right. So you send us some photos, and we're also going to give you 500 points on our contractor rewards as well. And if you don't know anything about that, look it up. We'll let you know. All right. So picks from the field from this week. I was looking around at some control projects here, and this wasn't a -5, but this was submitted. I got this picture from an old friend of ours, John, that used to work for a wholesaler in Peabody, Mass. All right, Mr. Gary.
Oh, okay. Gary Paul. All right.
Gary Paul. He used to work for a wholesaler up in that neck of the woods. Now he works for Crown Boilers. So he did such a good job in selling those boilers that he now works for the company. And so these photos, these weren't submitted through Picks from the Field, but these were pictures that I had. What I liked about this photo was what the contractor did with the -4 control. And if you noticed, you could barely see any of the wires. Everything, he tried to hide as much as he can.
Mhm.
All right. Now, what we can do with the -5s, if you haven't noticed yet or been to any of the webinars, he could have actually taken the wires right through the back of the control, because the -5s have back knockouts as well now, and you can come around the back. He tried to hide everything with that 1900 box there coming through instead of having individuals. So I thought that was nice and clean. I thought that
Very
was
nice.
a setup there. But with the -5s, you can get rid of all this loose BX and just come out right in the plywood right there and run it behind and come in through the back of the control itself. So I thought that was I like that that setup there. It was nice and neat, and especially coming in tying in with the conduit here as well. So
It's the
so that
Christmas
was one
boiler
pick.
room. It's the Christmas boiler room with the
Yeah, it
with
is.
the red and green.
Yeah, big old red boiler. Yeah.
God bless us, everyone.
So this was one project, and then he had another one as well. And this one, he did go through the back. He almost went through the back of the board because you can't do it through ours, but he did. And this is again from Gary. These were also the wires did go through the board and come around the front side here like this. So he was trying to do that, but there was not enough room in the old -4 controls. But now we're at the -5, our latest version. You could have just hidden all that BX and just feed out and punch out right into the circular like he's showing here. So, so this was another one. This was showing some radiant with a thermostatic mix valve. But this was a high temp system, and he threw in a hydro separator here. So it wasn't a wall hung, but he did a high temp with a hydro sep, which I liked as well. So tying into the system itself.
Very nice. Very nice.
Yeah, so a couple nice projects out there. So
Yeah.
if anybody out there has some pictures you want to show off, you want to flex a little, send them in.
Bragging rights, guys.
Time to brag. Yeah, time to brag. That's it. Hey, Dave, I do want to bring up one question. We didn't prepare for this, but we were again. You and I both were reading on Facebook. I think it was the Boiler Guys group, and this is an important thing I'd like to just share with everybody right now. The flashing question was up about the flashing orange light on a 007E. And it was in it. Basically, the thing is, if you see an orange light of any kind on a 007E, 0015E3, 0018E, that's normal. right? That's normal. It's working the way it should. But explain the flashing yellow light or flashing orange light, because the guy was thrown by that and he wanted to know if there was a problem.
It was, but it only, so he sent the video. It was shown just once where the lights flashed a couple times, but that's when it powered up.
Right.
And basically what it was the software and everything, the circulator was waking up and saying, hey, what's going on here? All right. Oh, first thing I got to check, I got to see if we got water in the impeller. All right. And in the volute. So therefore it doesn't go into the sure start mode. And then it makes sure that it can spin. So it's just a diagnostic. So it'll happen on every startup. So on the circulator, when it's running like a 7E and a 15E, the normal operating color is orange. It's going to flash a couple of times and then just stay solid. If you see color change in that LED, that's when it goes through the sure start mode.
Right.
So white will tell you that it's trying to purge air out of the volute. White red will tell you that the impeller seized and it's trying to free itself up. So those are basically the three colors that you'll see. And the white is a quick 2-flash white, and then it goes back to orange. You can know the difference between white and orange. And then when you see white, red, and then back to orange, that's also very noticeable. So, but the standard orange is just a quick flash when the pump turns on for the first time. It doesn't stay solid. It's just basically saying, hey, let's go and check everything, make sure we're cool.
And the other thing to note too, red doesn't mean the circulator's dead.
Right. Yep.
Red doesn't mean the circulator's dead. Red means the circulator has shut itself off. It protects itself thermally so it doesn't overheat. So if the impeller's blocked and sure start can't unblock it, the light will turn red, but the circulator shuts off, and that's a signal to come, check it out and see what's going on. It's not a sign that the circulator is bad and needs to be replaced. It's just a sign that it has shut itself off, and you need to figure out what's wrong, what's causing that to happen. Usually it's either airbound and it couldn't get the air out, or there's something physically keeping the impeller from spinning.
I normally just tell everybody to turn the power off to the pump, turn it back on again, let it do its function all over. And if it doesn't clear itself in 15 minutes, then you got to figure it out and take the pump apart and see what's going on, or purge. Okay, make sure you're not airbound, things like that. So,
but red is not dead.
All right. Last section of Takeaway After Dark tonight is, where in the world are the three of us gonna be? All right. Now, we are all in the home office. So I got home today. As a surprise. So I got home. Jason's home. John's home. So where is everybody going to be, and where can you come and hang out with us?
And Tony's home too, for a change.
Tony's at home too.
No, Tony's
not yet.
Not yet. Tony's in Toronto.
Oh, not yet. That's right. You're in Toronto. That's right. That's
Toronto,
right.
yes. So Tony, I don't know where you're going to be coming up in the future, but I got a couple of slides here. So I got Jason.
Yo,
Terminator here. All right. Where are you going to be, Jason?
I've been looking forward to Sci-Fex for a couple of months now. It's a pretty prominent HVAC electrical trade show in Vancouver. I'm a guest speaker there, discussing the finer points of heat pump water heater research.
Oh, very good.
Very good. From the
Great
3
topic.
to 3 to the 6. And to echo what Tony was saying earlier, we try to learn something. It's going to be a big learning event. So try to learn something each day or every day. So I'm excited for the opportunities to learn from our brothers up north of the border. And shortly after, the week after that, I'll be doing back up into the Northwest in Washington and Idaho. I do a full day sort of hydronics boot camp, focusing on our new Dash 5 controls in Sandpoint, Idaho. So please try to get with your local rep or your wholesaler to find details on how to attend that. And also November 13th, back to Spokane, Washington, to do a similar curriculum. So
one of my favorite towns right there, Spokane.
Really, really, I haven't spent much time there, John, but I'm looking forward to getting there.
Awesome.
Awesome.
All right, Dave in the East, the Prince of Darkness. I just love the way that photo worked out in this.
Oh, God.
I am going to be in November, so yes, I'm home for a little bit right now. I got some other things going on locally here and there. I will be at the Pennsylvania Petroleum Association Tech Training Center in Grantville, Pennsylvania, for 2 days. I think it's 2 sold out classes already on the November 13th and 14th, where I spend a day going over my the hydronics gold portion for NORA, which I will then repeat again in December 3rd and 4th. And the OESP Central Massachusetts chapter, that's a tentative. I don't know if that's going to happen. But if anybody here is a member of OESP, or if you're not even a member and you want to be, or you're not even sure what the heck OESP is, check it out. All right, check out that organization. I may be the speaker there. I may just show up there and hang out that night as well. And that meeting is in Auburn, Mass. in the evening. So we've got lots of different chapters of OESP all over the place. So it's the Organization of Energy and Service Professionals that we have out there. So it's a heavily Northeast group of people, so to speak, or the East Coast, not necessarily Northeast. But if you're familiar with it, come on by. So that's where I'm going to be.
Good stuff.
Let's see. Where's JB cover? JB's wherever. It's good to be king.
It's good to be the king,
right? And you know what? It's still good to be the king.
Yep. JB's going to be homebound for some.
Yep. And you
some
know
good
where you're
reasons.
after that? It's being the king at home takes work as well.
That's right. That's right.
So John's got no travel plans at the moment, but you know what? That's what happens. It's getting towards the end of the year. People are out there fixing stuff, and so our training season starts to slow down a little bit, and we've got plenty of other work to take care of. Tony, what do you got going on? Do you know where you're going to be?
Yeah. So next week I'm going to be in Cranston. I'm actually spending the better part of the week up there doing testing on our new booster platform. And then once I get done there, I get home for a couple of days, and then I'm off to Atlanta for the better part of a week with our rep in Atlanta, Hoffman Hydronics. I am doing their PDH marathon for them, presenting on flow-through expansion tanks and control valves.
Awesome.
And then spending some time doing some engineer visits with them in both Atlanta and Macon.
Excellent.
I get home, I'm home for 2 weeks, and then back on the road again to Raleigh and Charlotte, hanging out with the guys at Hoffman Hydronics again, doing PDH marathons and a bunch of engineer visits, and actually get to go to a job site and figure out when Sam Hill, a hot water boiler, is not working right.
Yep.
Oh boy.
I think that's the one you and I were talking about. That's right. Yep.
Yes. Yep.
All right.
So that's my crazy schedule.
That sounds normal, actually.
Yeah.
For at least for the three of us. Yeah, that sounds pretty normal for the four of us here. Yeah. That's just another day, you know.
Yep.
Whoops. So what's coming up next? Our next, and I believe our last episode of the year. Okay. But I got to double check that. Maybe not.
It's the last episode of November. I don't think we got another one scheduled for November, unless we do one the 19th, because we're not going to do one just before Thanksgiving.
Yeah, no, I don't remember right now, but I do know the next Takeaway After Dark Live is going to be November 12th. We're going to talk about zone pumps versus zone circulators and that great debate going on there as well. And our special guest that we're going to have there is going to be Leslie McGlennon. All right. And if you don't know who Leslie is, take a look on the socials out there. She has a plumbing and heating company called the Pipe Wench. All right. And that is probably also her handle on half the social medias that are out there.
Especially Instagram. Yep.
Yeah, especially on the Instagram side of things. She's a good friend to Takeo. We've known her for a lot of years, and probably one of the hardest working women I know.
Yep. And you captured it right there. Fresh and fearless perspective. That's Leslie to a T. Yeah, absolutely.
100%. Yeah. So that is going to be a rip. I can't wait for that session to happen. I will be on the road because I will be down in Pennsylvania that day. So I'll probably do it live from the PPA lab, where we have a working lab in that facility as well. So I'll probably do it from that night there in the facility. So it's a pretty cool place. So we're not going to see skeletons bouncing on the screen behind me.
And as I recall, at our last Takeo Cup golf match, she kind of ate your lunch, didn't she? She took your lunch money away, kicked your dog, and kicked your butt. Did she not?
Ooh.
I didn't play Leslie. No, I didn't play against Leslie.
Okay. Who did? It was Masterson she smacked
yes.
around. That's right. One of our area sales guys. Yeah, don't get into a golf match with Leslie. She'll steal your lunch money. Absolutely.
Yep. All right.
All right, guys. That was awesome. That was so fun.
That was a really good session tonight. I know
Absolutely.
we did.
Thanks for inviting me. I appreciate
Hey,
it.
thanks for joining us, Tony. It's great.
Thank you, Tony.
Yep, I had fun. So thanks for inviting me. I look forward to being invited back.
Well, we'll
There
see
you
about
go. There you go. Just you're gonna have to get into a costume next time, other than the adult in the room. Well, that's a perfect costume right there. I think that was great.
Everybody, thank you joining us on another episode of Takeaway After Dark. This was a lot of fun. JB, Jason, Tony, T-Bone.
it. JB,
Thanks, everybody.
T-Bone.
All right.
Thanks, everybody.
See you later, everybody. Thanks for joining us.